Hi students, let us discuss the paper of NEET 2026 which was conducted on May 3rd, Sunday. So that exam paper physics part we will be discussing now. So on the screen you can see the first question which is given in the NEET entrance exam. So the first question is a 100 turn closely wound circular coil of radius R is equal to 5 centimeters and a magnetic field B of 3.14 into 10 power minus 3 Tesla at its center. So the current flowing through the coil first. So generally for a circular coil at its center B is given as mu naught number of turns Ni by 2R. So first we'll use this to calculate I. So that is B. So B is 3.14 into 10 power minus 3 into 2 into R is how much? 5 centimeters. 5 centimeters is 5 into 10 power minus 2 meters by the number of turns, that is 100. We can write it as 10 square, and mu naught is 4 pi into 10 power minus 7. So this is how. But pi and 3.14 cancel. So this is 10, and this will be in the numerator 10 power minus 4. In the denominator it is 1 by 4 is 4 is there, that is 0.25, and in the denominator we have 10 power minus 5. So when it comes it will become plus 5. So it is 0.25 into 10. So it comes around 2.5 ampere. So 2.5 ampere, two options are there. But we need to calculate magnetic moment too. So magnetic moment of a circular coil like a solenoid, if I take, it would be nothing but equal to NIA. N is 100, we'll write it as 10 square. This is 2.5. I just now we calculated I as 2.5, and the area of cross section would be pi into R square. R square is 25 into 10 power minus 4 because it is in centimeters square. We have converted to meter square. So 25 into 25 would be 625. That will be 62.5 into 3.14 into 10 power minus 2. But if I take 3 twos are 6, just roughly I'm calculating, 3 6 are 18. So this will be 186 into 10 power minus 2. So that is around 2 it comes out. 200 we can say, because nearest answer is 200 into 10 power minus 2. So that comes out to be 2 ampere meter square. So the first option will be correct. Okay. So now let us go to the next question here. Okay. 1 second. So now the second question here is, we are having the second question here. So that is the matrix match question. So in this matrix match question, okay, now we'll see the second question. So it's a matrix match question. So here, first it is given that E is equal to H nu. So E is equal to H nu is the energy of a photon. Next, diffraction and interference will explain the wave nature of light. So B3, and we have A4. So first and fourth option we have, and lambda, that is a wavelength, is equal to H by P. So that is nothing but de Broglie wavelength, C1. Okay, and Compton effect explains about the particle nature of light. So first option is correct here. So A1, A4, B3, C 1, and D2 is the answer. Okay, now we'll see the third question. So it's a semiconductor based question. So the current in the circuit shown below with all four diodes which are being given are ideal. So first we have to look into that what is the condition. So first we have to check which diode is forward biased and which diode is reverse biased. So what is the condition is, in a forward biased condition, In a forward biased condition, a diode acts as a short circuit. Diode behaves as if, let us suppose we take D1 diode, this is D2 diode, this is D3 diode, this is D4 diode. So now here plus is connected to positive here. So this is forward bias. So it is acting as a D1 is acting as a short circuit. Similarly, you go to a reverse bias diode. So reverse bias diode means when N is connected to positive. So D2 is reverse biased. So it will act as an open circuit. Open circuit means you can't have the current flowing through that part of branch. So now go with the same as D1, D3 is also connected. So that is short circuit and D4 is open circuit. So now remove this portion and remove this portion. So now this will act as a short circuit. This will act as a short. So 4 ohms, 2 ohms are there. So let us redraw the circuit. 4 ohms and we have 2 ohms and that is connected to a 10 volts battery here. So that is 4 and 2. 4 into 2 by 4 plus 2 is R equivalent here. So that is 8 by 6. That is 4 by 3 is R equivalent. So the question is to calculate the current here. So current is voltage, that is 10 by 4 into 3. So this is 5 by 2. 5 threes are 15 by 2 amperes. So the second option would be the correct option here. I think you understood. Now we'll answer the fourth question here. So the fourth question is, here we have light taken as unity, that is 1, and that is the velocity of light, but the time is given as 6 minutes and 40 seconds. So what is the total time in seconds we'll take? So that is nothing but 6 into 60 seconds plus 40 seconds additionally. So total 6 6 are 36, 360 plus 40. So it will be 400 seconds. So that is the time. So we want distance. Distance is equal to velocity into time. So velocity is, if I take it as 1 unit, that is unity, that is nothing but 3 into 10 power 8. So the velocity of light is taken as 1 unity. So as unity, that is 1. 1 means here 3 into 10 power 8 meters per second. One unity they said. So the one value of C, one new unit is equal to 3 into 10 power 8 meters per second. So the distance in units we have to take. So that is, we have to take in new units. So in general, the distance would be, the distance in the old value will be 3 into 10 power 8 into 400 seconds. So that is nothing but 3 fours are 12 into 10 power 8. But here we have to take only for 1 unit. So that would be 400. 400 would be the value. 400 would be the value. Okay. Okay, now let us answer the fifth question here. So the following plots will show the variation of velocity with time, and it is about the ball thrown vertically upward. So using the sign convention, because velocity is a vector. So let us take this as my reference point as the ground. So now from that, what happens is all the values which are projected for any vector in upward are taken as positive and below the reference line as negative. So in that sense, let us suppose we have a body projected with an initial velocity u in the upward direction. So we'll take it as positive and it starts with u. So it goes to a h max where at H max the velocity becomes zero. But again, instantaneously, the body changes the direction and falls towards the ground, and it will be in the negative direction. So let us take that here acceleration is equal to minus g in this case, because it is always acting in the downward direction. So now it is retardation. So V is equal to U minus GT. So here it is like a straight line graph. First, all the first four are straight line. And in that, you have to start with plus U. So plus U, here we have U. And after the time of ascent, its velocity will become zero. And from there, it again becomes negative. So further continues. So C option, only C option would be the correct option here. Okay, now we'll see the question number 6. So here it is given that in a 1 year calipers, 20 VSD is coinciding with 20 VSD is coinciding with 16 MSD, and it is also given that 1 MSD is equal to 1 millimeter. But what is the least count of a 1 year calipers? 1 MSD minus 1 VSD. So from this, we can write that 1 VSD is equal to 16 by 20 MSD. That is 1 VSD. So 1 MSD is 1 mm, and this is 16 by 20. So we can write it as 2 8s are 2 10s are, or 4 table also 4s are 5s are. So 4 by 5 mm. So now we'll just substitute it here, 4 by 5 mm. 5 minus 4, that is 1 by 5 mm, or that is 0.1 centimeter by 5. So that is nothing but 0.02 centimeters. So third option will be the correct answer. So now the question number 7 here. An AC circuit contains resistance of 1 kilo ohm and a capacitor of 0.1 microfarad and an inductor of 1 millihenry connected in series. So it's a series resonant circuit because the resonance frequency is asked here. So according to that, the resonant frequency formula, direct question, it is 1 by 2 pi under root LC. So that is 1 by 2 pi under root L is nothing but equal to 1 millihenry. So that is 10 power minus 3 into 0.1 into 10 power minus 6. So that is 1 by 2 pi root of, if I take this is 10 power minus 1. So 6, 7, 8, 9, 10. 10 power minus 10. So that is 10 power 5 by 2 pi. So that is 10 if I take 5 by pi into 10 power 4. So we can write this as 50 by 3.14 into 10 power 3 hertz. So this will become kilohertz, and 50 by 3 approximately will take. So ones are 3 ones are 20, that is 6, and like that 16, around 16 means 15.9. So you have third option. So third option would be the correct answer here. So now we go to the question number 8 here. So the figure shows a long straight solenoid wire or a solid wire of circular cross section of radius A carrying a steady current here. So now here we have to calculate what is the plot of the magnetic field induction versus its distance R. So B versus R graph. So now we start from the R less than A. So that is a point inside that solid wire. So now when I take R less than A, so at that time, the B will be proportional to R. So it would be a straight line till R equal to A. So there it becomes B max. Then when R greater than A, so then B will be inversely proportional to R. So that is outside the wire. So now we'll just go with that. So this will be a rectangular hyperbola. So now we will just see the plot of the graph. So here B is proportional to R, here B inversely proportional to R. So this is a curve, so it won't be the answer. This is also a curve, it won't be the answer, and this is also not properly given. And here B is 0, this is also not correct. So the first option will be the correct answer.